Again, in a non-relational, in a relational database, you have a couple of choices. Typically, you would implement one-to-many relationship in a relational database by using a simple foreign key. In this case, we have two one-to-many relationships: faculty to courses and faculty to sections. Yes, and the way you would implement it typically in a relational database is that a course and section would have foreign keys pointing to the faculty, right? That's the most common way, right? You could also just use again a mapping table, right? Mapping table is it's the most generic way to create a relationship between any records, yes? Where you have two pointers, two references to the records that are related to one another, yes? But more commonly, it's implemented by using foreign keys of the child pointing to its parent, right? But again, you could still use a mapping table. So the classical way to implement it is that the children section points to the faculty, or the course points to the faculty that they belong to, and or right, you can use one or another. You can say faculty, that section that they taught, and faculty the courses that they authored. You would point to the section that they're teaching, or the courses that they've authored, and you have an additional choice. You have an additional choice, right? Not that this would make any sense, but you have this choice. You can embed the entire object, right, inside of the parent object. Here we're using references, right? We're using the foreign key. We're pointing, we're having the ID of that other object that we are referring to. Or you can actually put the entire object in there, right, as an embedded object. Okay? Now, this would only make sense if the child object, right, wholly exists in the parent object. That there is no way for the child object to exist on its own, right? And so that if the parent is removed, then all the children objects are also removed. Then it would make total sense that those objects would be embedded in here. Okay? But if those objects have any meaning outside, right, of the parent object, then it would make no sense to embed them in here, right? That it would be better to actually just reference them, right? So an example might be, if you're an application that we're building in web dev, we have, or actually here we played around with that a little bit, right? We have a website contains many pages. A page contains many widgets. Yes, and then you have any number of widgets, right? And so you might want to ask, well, what do we do then? Would those each one of them be collections? Well, maybe, right? If the item can exist on its own, right? Like for instance, a website, perhaps can exist on its own. Maybe I want to be able to list all the websites for all the users, regardless of who the user is. It'd be a good idea to have a list of all the websites in its own collection. Yes. And then you have the pages. Right? Well, you might want to ask and say, well, are pages wholly contained inside of a website? Meaning, if I remove a website, does the page record still exist? Right? Can the page exist outside of a website? Well, maybe, right? Maybe you might have pages that are shared amongst multiple websites. Maybe they all share your login and registration. They all share a couple of headers and footers and whatnot. Maybe, I don't know. So in that case, maybe it makes sense to have its own collection. Right? Maybe you want to be able to list all the pages, regardless of what page, which website they belong to. But more and more you get into other elements that belong to their parents. For instance, you get to the widget, right? You get to the widgets. Would widgets make sense for them to exist outside of their page? Probably not, right? If I remove a page, typically I would not want to keep track of all the records for the widgets. Yes. And so if I remove the page, probably want to remove all the widgets inside of that page. Make sense? So those particular records might make sense to just embed them, literally inside of their parents as an array. Right? This is the array of all the widgets embedded in there, right? And I have if those widgets are not shared amongst multiple pages, then I don't have any redundancy risks, right? Because the widget only exists, that widget instance wholly ever exists inside of that particular page, yes? If instead, if it's a record that might be shared amongst different places, then maybe embedding is not a good idea, right? Because then I would be redundant, right? I would be inserting that embedded object twice and being, or 3 times or multiple times in the embedded, in the parent that I'm embedding inside. Make sense? So again, so if you have things that are shared, that are have multiple references, perhaps it's a good idea to have its own collection. If it's wholly represented and it makes no sense to have its own representation, then it should be embedded. Ideally, we would try to, as much as we can, as much as we're allowed to implement our own structure for the data, and we would try to, as much as we can, and use this representation, right? Embed all the data as much as we can to minimize any references to any dependencies with other collections that might cause me to have to do an additional query, right, on those other collections, right? And again, minimize joins, minimize any of that, right? Obviously, sometimes we can't, and we have to do queries, and we have to do joins, and we do have to do that. But to the extent that we can reduce any dependencies between documents, we should take those opportunities. So here's the example of faculties, sections referring to the faculties that are teaching those sections. And so here's an example of setting the faculty pointing to a reference of that faculty, or embedding the objects, right? So for instance, in this case, we have, notice that we are documenting here using composition, right, to denote that these are wholly contained inside of their parents, right? If I remove the lesson, all the topics are gone, right? If I remove the module, all the lessons and all the topics are gone, right? So there's a life cycle dependency between these two, right? Same thing with course. I remove the course, everything is removed. But if I remove the faculty, right, the course would survive, right? So this is not wholly contained inside of the faculty, right? It's only a reference, as opposed to wholly contained in an array inside of the faculty. Make sense? So you would capture this in the UML, and that would give you a hint on how you would implement it in Mongo, right? Whether it's embedded or not embedded. Make sense? So here's just graphically represented where you have topic 1, topic 2, and then you're saying lesson 1 dot topics wholly contains the objects topic 1 and topic 2, and then the module 1 contains several lessons, and then the course contains multiple modules, right? So we have the courses containing several courses, course 1 containing several modules, module 1 containing several lessons, and so on and so forth, right? And these are all embedded objects. Yes? Right? The challenge of having such an embedded object is that it's very hard to navigate through, right? And it's very hard to do queries that match. Again, so if you're doing matching of fields at the high level of the course title maybe, well, that's easy to create matching queries, right, that match fields at the top of the object. But as you want to query embedded objects, it becomes more and more complex, right? And there's some limitations on how Mongo allows you to manipulate embedded objects. And we'll see some of those limitations. So here's an example of building up these objects. So for instance, here we have db.modules. And we're inserting a module 1, and we're inserting then an embedded lesson that has a name lesson 1. See that? Right, so notice that lessons contains an embedded object inside of a bigger object module. See that? Right? And we can then push a brand new lesson. Here we have 2 lessons, right, as an array of a bigger object. Well, what about inside of lessons? I want to insert. Here I am retrieving from modules. I'm retrieving the lessons, only the lessons, right? It contains the array of lessons. How about topics? So here we have inside of modules has lessons. Now I want to insert a topic, which is another embedded array, right, of embedded objects, right? So how do I do that? Notice the syntax here is fairly complex. One of the things that we're going to be able to have to do is to use the operator, the $ operator, also called the positional operator, right? Notice how this works. It says, I'm going to update the module whose name is module 1, yes? And lessons is an array. Lessons is an array. I can refer to fields in the objects of that array, right? Dot name. What is that going to do? It's going to iterate over the lessons array, matching all the name fields in that array. See which one matches lesson 1, right? There could be 10 lessons, yes, and the third matched, yes, right? Now I like to be able to refer to that third document, embedded object. I like to be able to refer to it because maybe I want to manipulate it, right? That third object, I can then say set lessons. Again, it's an array. And then I can say, well, which one? Which lesson? The first one, the second one, the third one, which one? Right? $ takes on the value of the one that matched in the query. The query maybe was the third one that matched. Make sense? So $ means the third lesson, the third element in the array. Okay? Well, now that I've determined that it's a third lesson, I can now refer to the topics array that's in there, right? I can say, okay, what do I want to do? I want to set it, right, and give it an array of topic 1. Okay, so now I've added to the third or fourth or fifth or whatever lesson, I've added here name topic 1, right? I can do it again. I can push again into this topics and add a brand new topic, right? Now the $, positional operator has a limitation. Let me point out the limitation.